So this lecture is to cover 2.3 on functions and relations. You should have the PDF printed off, and as we go through this lecture, you should be taking notes. So we're going to first talk about our objectives. We're going to determine whether a relationship is a function. So we're going to define what makes a function and then look at various examples. We're going to look at just points. We're going to look at an algebraic representation of a relationship, and then we're going to also look at a graph and be able to say, is this relationship a function? We're going to look at function notation. We're going to determine x and y intercepts of a function. Again, we'll do that algebraically and we'll do that graphically. Determine domain and range and interpret a function graphically. So the first thing we need to do is define relationship. So the definition of a relationship is just going to be an ordered pair, right? X comma y. So I put in x, I get out y. The x values, the inputs, are the domain of the relationship because we haven't determined if it's a function or not. The y values are going to end up being the range of the relationship. So let's look at the kind of first example, and this again is on notation here. If I give you this relationship, saying I put in 3 into the function, I get out -4. I put in -2, I get out 0. I put in 5, I get out 3. I put in 1, I get out 0. So the first example wants me to write the set of ordered pairs that define the relationship. So that set would be 3, -4, because 3 and -4 are paired together. -2 and 0 are paired together. 5 and 3 are paired together, and 1 and 0 are paired together. So there's 4 sets of ordered pairs. The domain of this relationship would be the inputs, and those are going to be the x values. That's going to be 3, -2, 5, and 1. The range are going to be the y values. They're going to be what I get out. In this case, it'd be -4, 0, 3. And then we could write 0 again, but in our notation, we're not going to write things more than once. So if they're listed 5 times, we just say the range is one of them. We only need one of them to meet that criteria. So I put in 4 numbers into this machine or this relationship, and I get out 3 unique numbers, either -4, 0, or 3. So that's just kind of the notation on relationships. And of course, we don't do much in college algebra with relationship unless it's a function. So we want to define function. So y is a function of x if for each x value there is exactly one y value. So what's that saying is for every x there's only one y value. So let's look at part A and B here of determining a relationship as a function. I'm going to start with A here. I have 3 goes to 1, 2 goes to 5, -4 goes to 2, 1 goes to 0, and 3 goes to -4. So I'm looking for every x, it can only go to one y. So 3 is 2, -4, -1, 3. So the only thing I have to be concerned with is these 2 points. And here this is saying 3 is mapped to 1, and it's also mapped to -4. This gives me a problem, right? 3 can't go to 1 and -4 at the same time, so this is not a function. The next example, we have 1, -1 goes to 4, 2 goes to 3, 3 goes to 4, and -4 goes to 5. All the x values are different, right? So it doesn't matter. Some students would, look at this point and look at this point and maybe say we have a problem, but there's no problem here. No problem. We're good. We're happy. because every x is different, right? Remember the statement says for each x value, it can only go to exactly one y value. So it doesn't matter that more than one y is paired up with a different, or it doesn't matter that the same y is paired up with different x's. That's fine, that can happen. That actually happens when you have a straight line, right? So this is a function. So yes, function. This relationship is a function. We can also look at this graphically, and we can apply the vertical line test. So the vertical line test states that if I can draw a vertical line, right, the graph defines y as a function of x if no vertical line intersects the graph in more than one point. So if I look at a graph and I draw a vertical line and I intersect the graph at more than one point, I can say no, not a function. What this is saying is 2 goes to 2 and 2 goes to minus 2. So 2 gets mapped into two y values, two different y values. And we have a problem when that happens. So graphically, it's almost a little bit easier, is because all you have to do is draw a vertical line anywhere in the graph. If it only touches the graph at one place, then it is a function. Each individual vertical line, right? It only touches it there, it only touches it there, so forth. So this is a function. We have to be a little careful with piecewise continuous functions, right? So if I draw a vertical line right here, I cross the graph in two places. So this would be not a function. Again, that point is saying x is minus 2 and x goes to at x equals minus 2. My y values are 2 and 4 at the same time. That's a problem. All right? So we'll do some more examples of these, and you have some in your homework. And remember, practice makes perfect here, so you want to get as much exposure as you can to these types of questions. So function notation. So we want to know, a lot of times in math we try not to use a lot of words, and we just try to use symbols. So here this is saying evaluate these functions at these x values. So if this is our function, we want to plug in here x equals minus 2. We want to plug that into our function for x. So really this is saying, what is g at minus 2? Well, that's taking 2 times minus 2 plus 1, which is minus 4 plus 1, which is minus 3. Here this is saying g at 1, so I'm plugging in g at minus 1. The x value is what's in parentheses here, this x value. So that's going to correspond to any x value in the function or in the relationship. So I have 2 times minus 1 plus 1, which is minus 2, plus 1, which is minus 1. G of 0 means I'm plugging in 0 for x. 2 times 0 plus 1, which would be 0 plus 1, which would be 1. And you can, finish the other two. The skills practice here, again, straightforward for this value. You want to be able to plug in what is h of minus 3. So I take the expression h, 4 times minus 3, minus 3, minus 12 minus 3, minus 15 would be the answer there. And doing the next 4 here by plugging that into the function. What would h of minus 1 be? H of 0, h of 1, and h of 3. Now there might be, instead of plugging in a number, we might plug in another variable. So m of t is saying I'm taking the function name m And everywhere I have an x, I'm replacing that with a t. So here's my variable here, and I'm going to take that, and everywhere I have an x, I'm going to replace that with a t. So I have minus t squared plus 4t. So it's minus t squared plus 4t. Here, everywhere I have an x, I'm plugging in a plus h. So it's minus a plus h quantity squared plus 4 times a plus h. And I cannot stress this enough. Parentheses are your friend. Parentheses are going to hold you accountable for anything that's going to maybe distribute, right? If you drop those parentheses, 4a plus h is different than 4 times a plus h. So simplifying this, you're going to expand this out, a plus h squared. So a plus h squared, if you recall Math 110, this is a plus h times a plus h. And if you do the FOIL method, you end up with a squared plus ah plus plus h squared, which is a squared plus 2ah plus h squared. Right? So if I plug that in, I have negative, I want to keep my parentheses, a squared plus 2ah plus h squared plus 4 times the quantity a plus h. So the last little bit of cleanup is to get rid of my parentheses so I can distribute everything. I have minus a squared minus 2ah minus h squared plus 4a plus 4h. So I know that's kind of long here, but that's kind of the most difficult thing you're going to come across in this section. You might be plugging in a number, you might be plugging in another variable, or you might be plugging in a sum of variables. If you're plugging in a sum of variables, be very careful to keep those parentheses. Determine x and y intercepts of a function. So our next objective here would be to find the x and the y intercepts of a function. There's kind of two approaches here. You can do it by graphing and knowing the shifts, or you can do it algebraically and know that the x-intercepts are going to be when y equals 0. The y-intercepts are going to be when x equals 0. Right? So in this problem, if I want to find the x-intercepts, I plug y equals 0. And y is f of x. So this can be written as y equals the absolute value of x minus 5. So I want to solve for when y is 0. When is the absolute value of x minus 5 equal to 0? So I add 5 to both sides. And when does the absolute value of x equals plus 5? Well, at x equals plus 5 and at x equals minus 5. Right? The absolute value of negative 5 is still positive 5. So this point here would be 5, 0 and minus 5, 0, right? As we said before, our x-intercepts, oh, I wrote that wrong, sorry. Our x-intercepts are when y is 0, no, that was right, sorry. 5, 0 and minus 5, 0. Like I said before, it's when y is 0, so our y component is 0. Our x component is whatever we need to plug into our function to get out the 0. Remember, x is what we plug in, y is what we get out. So I can test this by plugging in absolute value of 5 minus 5, absolute value of minus 5, minus 5, 0. So that works there. And then looking at our y-intercept, it's when x is 0. So when y equals absolute value of x minus 5, I'm going to plug in when x is 0. So that's going to be the absolute value of 0 minus 5, which is minus 5. And that gives me the point 0, minus 5. right? And we said the y-intercepts when x is 0. So our x component is 0. What is our corresponding output? When I plug 0 into the function, I get -5. Determine domain and range of functions. So we kind of did that with relationship, but now we know it's a function. So the domain here, domain is the x values, right? The x values. So this dot has a corresponding x value of -3. This dot has a corresponding x value of 1. This one has a corresponding x value of 0, 2, and 4, right? The x values. So if I was to write that, -3, -1, 0, 2, and 4. The range is going to be the y values, right? So here this dot has a y value of -4. This dot has a y value of 1. This one has a y value of 3. This one has a y value of 4. That one also has a y value of 4. So if I wanted to list the y values, it's -4, 1, 3, and 4. They can be in a range. So if I go the domain here, it goes from -3 and it's open, so I'm going to use a parentheses. All these x values have output, so keep going, keep going. It actually keeps going forever because this arrow tells me it just keeps going. So this is -3 to infinity. In the range, is going to be the output values, right? So it's going to output -2. All these are outputs. And continue to output all the way to infinity. So -2 to infinity there. So domain is x values, range is y values. Let's look at this example here. The domain, well, this arrow says it keeps going forever, and this area keeps going forever. So the domain here is actually -infinity to infinity. And the range is going to be 4, including 4, right? All these outputs here, all the way to -infinity. So 4 to -infinity. And we actually write that -infinity to 4 here. And on the 4, I'm going to put a bracket because it includes it. It's a closed circle. And when we had above, we had this open circle, so that's why I use the parentheses. So if it includes the point, I have a bracket.